Hello, I thought I would do some examples on this. I don't want to call it a set one, I think that should be enough. Examples of solving first order variable separable form of differential equation. I went through this in the last lesson, right? So, let's take an example. I think these pens are running out. I need to pick a new pen. Okay, luckily I'm going to finish my box of pens and my teaching as well. So number one, xy times 1 plus x squared dy by dx, xy times 1 plus x squared, no, 1 plus y squared, is it? No, 1 plus x squared dy by dx. Now let me make it xy times 1 plus x squared, y times 1 plus x squared dy by dx equal to x times 1 plus y squared. For which, solve. When x equal to 1, y equal to 1, giving your answer in the form y equal to f of x. I hope I'm just made up, so it's possible. First and foremost, I know it's first order, so but you don't know, you're not being told it is first order linear. I'm sorry, first order variable separable. I have written it because I know it is. So first job is make dy by dx the subject. So dy by dx equal to x times 1 plus y squared over y times 1 plus x squared. Why do we do this? So that you can see, you can bring the y's one side, x is one side. Multiply through by dx. So y over 1 plus y squared dy is equal to x over 1 plus x squared dx. I can integrate both sides. How do you integrate? It's a algebraic expression, a rational expression, a fraction. What the first rule for a fraction? Power on the top should be less than power on the bottom. Pum, 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 pum. Done. Then before you go any further, find out the derivative of the denominator. When I differentiate 1 plus y squared, I get 2y. I have a y. When I differentiate 1 plus x squared, I get 2x. I have an x. So, I will put a 2x and, I can do it here only 2y and a half and a half. So now numerator is exact derivative of denominator. So half ln 1 plus y squared equal to half ln 1 plus x squared. This is where we have to use common sense. We have been given initial values. You got an ln, right? And they want it in the form y equal to f of x. I got an ln, so I have to get rid of the ln. Whenever this is a common sense rule, no hard and fast rule, common sense. Whenever you have a log of a y function, call the constant as ln c instead of c. Makes life easier, as you will see. Multiply through by 2, I get ln 1 plus y squared is equal to ln 1 plus x squared plus 2 ln c. ln c is a constant, 2 ln c is a constant, or ln c squared is a constant. Leave it as ln c. Instead, call that as ln c. So I get ln 1 plus y squared equal to ln c times 1 plus x squared. So you got y squared equals c times 1 plus x squared. 1 plus y squared. So y squared equal to c times 1 plus x squared minus 1. I want a solution for which x is equal to 1, y equal to 1. So 1 equal to 2c minus 1. So 2c equal to 2, c is equal to 1. So y squared equal to 1 plus x squared minus 1, which is x squared. So y is plus minus root x. Or leave it as y squared is equal to x squared. Or y equal to f of x. Y is equal to plus minus root x. I can't help. You understand that? So unless you are good in integration, after step 1 in differential equations, you will fumble. Be careful. That's why I spent such a long time doing so many questions on integration, so many methods. Even when I did volumes, I went through so many examples so that you are thorough in integration. Let me take the other one. Solve the differential equation. Let me write it here. Solve cos y divided by dx equal to cot x 1 plus sin y, or I can say cos x divided by dx is equal to sin x sin x times 1 plus sin y. 1 plus 1 minus sin squared y. Okay. When x is pi over 2, when x is pi over 4, y is pi over 4. Alright? I just made up the question on the spot. Well. Apart from the fact that I'm a genius, I have to make sure the question works. I'm keeping my fingers crossed. I'm not too sure whether it's going to work or not. I hope it works. Right. So, dy by dx equal to sin x over cos x. 1 minus sin squared y is cos squared y. So 1 over cos squared y dy is equal to tan x dx. Boom. So sec squared y dy is equal to tan x dx. You must be able to rearrange. So that gives you tan y equal to ln sec x plus c. Alright? X is pi over 4, y is pi over 4. So x equal to pi over 4. Please don't put the initial values till such time you have finished the integration. Don't ever commit that mistake. If you put it in the beginning, you have a completely different differential equation, which is rubbish. Okay? Right. So tan pi over 4 equal to ln sec pi over 4 plus c. So 1 equal to ln root 2 plus c. So c is 1 minus half ln 2. So therefore tan y equal to ln sec x plus 1 minus half ln 2. That's how you solve that differential equation. Very good. Let me make my own question. Solve number 3. E power x minus y dy by dx is equal to e power 2y minus x, for which when x is 0, y is 0. I hope it works. Hopefully it does. Now, let me write that equation. E power x minus y dy by dx equal to e power 2y minus x. I can't separate the variables there, can I? So I'll write, okay, make dy by dx the subject is e power 2y minus x over e power x minus y. How am I going to group x with x and y with y there? Gentlemen, can you help me? Or ladies, can you help me? I don't know. Do you know? Basic algebra. X power m minus n is x power m times x power minus n. Can I write this as e power 2y times e power minus x over e power x times e power minus y. Now I can I say therefore e power minus y over e power 2y dy equals e power minus x over e power x dx. Ha ha! I've separated the variables now. So therefore, e power minus 3y dy equals e power minus 2x dx. Now I can integrate. So what do I get? I get minus 1 over 3 e power 3y minus 3y is equal to minus 1 over 2 e power minus 2y plus c. X is 0, y is 0. So minus 1 over 3 is minus half plus c. C is 1/6. Multiply through by 6. So I get minus 2 e power minus 3y is equal to minus 3 e power minus 2y plus 1. So I can say 3 e power minus 2x rather. So 3 e power minus 2x minus 2 e power minus 3y equals 1 will be the general. I took this question only because simple, basic algebra makes your life so difficult. Otherwise, you come to this stage, you start wondering, what do I do? I have seen when I gave a question like this, some students think they can do anything they want with maths because they're good at logs and exponential. So someone took ln. Log of a, so he said ln 2y minus x minus ln x minus y is ln dy by dx, and you're trying to solve. That would have led to a Nobel Prize if it had been solved. Because just because there is an ln doesn't mean you can take ln the way you want. When you separate the variables, you should only have dx and dy. You can't have ln dy and ln dx. Okay? So, I think I have time enough for one more question. I'm not too sure. Okay, let me do one more question. Let me take another question. Dy by dx equal to x minus 1 root y squared plus 1 over xy, for which when x is e, y is minus root e squared minus 2e. I wonder where the question came from. Find y in terms of x. That's a good question, I think. Look, dy by dx has already been made the subject, so you don't have to make dy by dx the subject. Let's look at it the way it is. So rearrange it. I get y over root y squared plus 1 dy equal to x minus 1 over x dx. Yeah? Root. Yeah. Now, how do you integrate this? Can I write this as y squared plus 1 power half times y dy is equal to 1 minus 1 over x dx integral. Now, I can't integrate directly. When I differentiate y squared plus 1, I get 2y. And I have a y. So the second look, I always start with, can I integrate directly? No. Can I use substitution? No. Can I use this? No. Can I use that? No. Yes. Somewhere it will be an s. So here it's a yes. So can I write this as half integral y squared plus 1 power half times 2y dy is equal to x minus ln x plus c. You might be wondering, why did I write ln c? I write ln c only if I had an ln on the left hand side. Now, when you differentiate y squared plus 1, I get 2y. So it's something like u power half du. It gives you u power 3 over 2. Oh, it's a minus half. So u power half over half. I can cancel the halves. So I get the answer as root of y squared plus 1 equal to x minus ln x plus c. Okay. Indirectly, we again revise methods of integration. Okay. Now, initial conditions. X equal to a, y is equal to minus root e squared minus 2e. So y squared is e squared minus 2e. So root of e squared minus 2e plus 1 is e minus 1 plus c. So what do I get? E squared minus 2e plus 1 is e minus 1 the whole squared. So therefore, when I take square root, okay, so it is e minus 1 the whole squared. Square root will be e minus 1 is equal to e minus 1 plus c, so c is 0. So root of y squared plus 1 equal to x minus ln x. So y squared plus 1 equals x minus ln x the whole squared. Y squared is equal to x minus ln x the whole squared plus 1 minus 1. So y equal to root of x minus ln x the whole squared minus 1. Now, remember when I put x as e, what do I get? E minus 1 the whole squared minus 1 gives me e squared minus 2e. But minus sign. Remember what I told you? If the question has a root, leave it as a root. But if you take a root, take plus minus. So for it to be consistent, this has to be minus. If you leave it as a plus, that condition won't be satisfied. Tricky, isn't it? So that's complete examples on, notes on differential equations, variable separable form. I don't think I will do the first order linear one, because if and when I do further maths, I will be doing that. So those who have variable separable form, homogeneous equations, reducible forms, please refer to further maths lessons on differential equations if and when I do it. Otherwise, your teachers will have taught you. And obviously, I am no expert. I am just a teacher. Your teachers know much better than me, okay, about your syllabus and the content and the approach. So I'm not going to do those. I will just now take up a number of questions on how to apply differential equations to practical questions. In fact, I'm going to do a question where you will become a detective and decide the time of murder. Yeah, hang on, we'll do it. I'll see you in the next lesson. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.